I'm sure you've heard about the butterfly effect. The classic, when a butterfly flaps its wing in China, it can produce a tornado in the other side of the world. But the butterfly effect is much more than that. It's about small changes having big consequences. Small changes are happening all the time, right now, everywhere around us, and even also inside of us in places we can't even see. For example, this can happen in our genes, or more specifically for our purpose, in bacterial genes. I call this the genetic butterfly effect because genes are like butterflies. Single genes moving can cause radical changes everywhere. Genes are usually thought of as something stable or fixed, but for bacterial genes, this is far from truth. Because their ability to move their genes allow them to become scapegoats, manipulating our body and the way we respond to their intrusion, defining the course of the disease. This means that if genes are what make us what we are, then bacterial genes are what make us sick. So we know that genes can move, but what could happen if we don't allow them to move? And I guess you'll be thinking, well, who cares if genes move or don't inside bacteria? But you should care, because this gene movement is what allows bacteria to create infections and cheat our immune system. It is what makes us sick. And this is what we suspect might be happening with Salmonella, a very common bacteria that causes fever, diarrhea, stomachache, and can even lead to death in small children and the elderly. It is the #1 cause of hospitalization for foodborne diseases worldwide. It is especially problematic in third world countries and developing countries with no clean water supply. Salmonella has this group of jumping flying genes called islands, and they are able to move around inside of the bacterial genome. But when we take these genes or avoid their movement, Salmonella stop acting like, well, Salmonella, and it makes us less sick. So why do these genes cause these changes? Are they changing other genes? Maybe without their movement, our bodies would react differently. Well, these are some of the questions that we are trying to answer in my thesis. The goal is to find out how these tiny changes in Salmonella can affect our bodies and the way our immune system responds to its presence. In the long run, this kind of genetic butterfly effect can open up the door to a whole new world of therapeutic treatments against the bacterial infections, in which focusing on small changes can have monumental effects. And who knows, maybe the next step against antibiotic resistance is just a butterfly's wings flap away.